the number of green apples, the number of red apples, and also they have mentioned that when both the red apples have been taken up, the process stops. And the random variable here is x, which is actually the number of apples which are taken when the process stops, right? So random variable is very important in probability distribution questions. So we have to take note of what and identify what are the x in this particular question. Which have been taken when the process stops. Okay, so this is what we have to look at. So basically identify what is your x. So in probability distribution, it's very important to identify what is your x here. So if you see what are those possible combinations of choices of taking up the apples, okay, so we can look into 3 different possible combinations here. So the first, okay, possible, we can write this down, possible combinations. So here you can first choose the R followed by the green and then followed by the R, or you can choose the green followed by R and then R. And you also have another combination with choosing R, and then going with the green. But then we have to omit this because here we can't take this choice here, as they have mentioned that your random variable is basically when your apples have been taken up, the process stops, and we have only 2 red apples here. And the idea is when the apples are taken up, the process stops, we can't proceed with the third one, which is the green. So we do not take note of the third combination. All right, so we only look into the first. So therefore we say Px equals to 3 is basically, all right, looking into P, probability of R G R plus the probability of G R R. All right, so here you have to look at the combinations. So you have 2 reds out of 4, all right, and then multiply with 2 greens out of 3. Why is it 3 now? Because 1 has been taken and it's without replacement, so we have to remember that. And then the next one is you have only left with 1 red, and balance you have only a total of 2 apples. All right, and then the same goes for the second combination, 2 out of 4 multiply with 2 out of 3 and then multiply with 1 out of 2. Okay, so here your final answer is 1/3. So we have shown this. Okay, so that's the first one. And then the next one, they mentioned that draw up the probability distribution table for x. So here you have to basically identify when x is equals to 2 and x equals to 4. So in this question here, we do not take note of x equals to 1 because x is basically the random variable where the process stops after the apples, the number of apples have finished. So here we do not take note of 1, because you need 2 apples in order to finish the 2 red apples, only then the process stops. So we don't take note of the x equals to 1. So we say Px equals to 2 is basically R. Alright, so that would be 2/4 times 1/3. So you basically get 1/6. And then Px equals to 4. So that's basically all the combinations. Okay, you have GGR, GGRR, and then you have got the other one which is GR. You can alternate them, and then you have R. You can maybe put RGGR. Okay, so you can do this. So finally here you can just say 3 times, because it's the same probability, you can just say 3 times of 2/4 multiply with 1/3 multiply with 2/2 multiply with 1/1, and your final answer here you will get half. Okay, so screenshot of this. Alright, so then what we're going to do is we're going to compile all of this into the table. So your table would be x, okay, and you have here Px equals to x. Alright, so we can write down 2 3, and 4. All right, so we have 1 over 6, 1 over 3, and this is 1 over 2. So we are done with the table, because they finally say, you just have to come up with the probability distribution. So you can finally say that this is the probability distribution. All right.